So yeah, it's kind of crazy, but it's 10th week Wednesday. We just have today and Friday, and that's it for classes. So yeah, that's it. A little bit sad. I'll miss you guys, but I figured. So today I'll spend a little bit of time just doing a bit of review. It'll probably be a bit of a clicker bonanza. I'll ask probably like 10 clicker questions today or something. So I hope everyone's here. And or if your friends aren't here, text them. Say you better come. Okay, you're gonna miss out on a bunch of questions. Okay. Okay. So let me I'm going to just write some of the stuff. So this is, when it comes to doing problems on the final, one very important part, it's very important that you can identify what kind of scenario you are dealing with, all right? So for example, if you look at your formula sheet, there's 8 boxes, and we've covered 7 of those, okay? So we have stuff for proportions and stuff for means. So we've got confidence intervals for one proportion, hypothesis test for one proportion, hypothesis test for proportions, 2 proportions, with 2 samples, confidence intervals for one mean with 1 sample, confidence intervals for 2 means, the difference between 2 means with 2 samples, hypothesis tests for means with 1 sample, and hypothesis tests for 2 means with 2 samples. All right, so we've got 7 methods there, and it's very important that you can identify which scenario you're dealing with, because if you think you're doing one scenario but it's actually another, you're going to be using the wrong standard error, you're going to use the wrong values, and all of those questions will go wrong. Okay, so it's very important that we can identify. So what we need to do, so I'm gonna kind of write first of all, are you dealing with a confidence interval or a hypothesis test? Okay, confidence interval or a hypothesis test, and the key here is you're going to kind of read the questions, and it's going to be a confidence interval if you see keywords, and this seems kind of silly, but you're going to see keywords like confidence, all right, confidence level, or if you see the word interval, these would be clear indications that you're dealing with a confidence interval. But other keywords would be things like the margin of error. Margin of error will also be another indicator, okay? Or you might see things like the upper bound, upper or lower bound, okay? Those would also be indicators that you are dealing with a confidence interval. So if you see anything about the upper bound or lower bound, these would all be indicators that the problem you have is a confidence interval problem. On the other hand, for hypothesis tests, your keywords, okay, apart from the obvious ones would be, the hypothesis or test statistic, okay? Okay, you only have test statistics if it's a hypothesis test, okay? But also a p-value. P-values only exist if we're talking about a hypothesis test, okay? Common to both would be things like standard error, do we have evidence, okay, of whatever, okay? Those questions apply to both confidence intervals and hypothesis tests. So those are not words that we would use to distinguish between one set of questions or another. But over here, if you see questions about a hypothesis, questions about a test statistic, or a p-value, that's a clear indicator that the problem you're dealing with is a hypothesis test. Yeah, question?
Now, in Chapter 9, there were confidence intervals, and we saw confidence intervals before.
Yes.
So, are they the same or
Yeah, they're different. So first of all, I'm talking about distinguishing between a confidence interval and a hypothesis test. The next part is distinguishing between proportions or means. Okay? Chapter 7 and 8 were with proportions. Chapter 9 was with means. Okay? So proportions, we have proportions. This is for categorical variables. So as you're reading the problem, if the variable that we're talking about is a categorical variable, that's going to be proportions. Okay? As far as proportions, you'll see keywords like proportion or percentage. These would be indicators that you're dealing with proportion. And then the other key aspect is that the data is provided as counts. Okay? They'll say like this many are read out of a sample of this many. Okay? So the data is provided as counts, so you'll have large whole numbers instead of some kind of average here. Okay? On the other hand, we have means when we are dealing with a numeric variable. Okay? Means applied to numeric variables. Keywords here, clearly mean, but also words like average and standard deviation. Okay? So if you see the word standard deviation as part of your data, that's an indicator that you are dealing with means. Okay? The other main indicator is that as you're reading it, it's going to be a numeric variable. It's going to be talking about your height or your weight or the amount of time it takes to do something, or the cost, or some kind of numeric variable. And in that case, you're dealing with means. Okay? And again, in the problem, you need to be given the standard deviation. Without the standard deviation, you cannot answer questions about means. So that's important there. Okay? So proportions or means, and then lastly, one sample or two samples. Okay? So basically, as you read the problem, you want to try to identify how many different n's are provided. Okay? If you can identify only one n, then this is a problem with only one sample. Okay? Because for a problem to have two samples, you need to have an N1 and an N2. Those values could be the same. You could have sample 1 have 20 values and sample 2 have 20 values, but you would need to identify that both samples have 20 values. You need both an N1 and an N2. Otherwise, it's not a two-sample problem. If you're just comparing the mean of your sample versus some value established from before that doesn't come from a sample, that's not a two-sample problem. Okay. Is that okay? So figure this out. Confidence intervals are a hypothesis test. Proportions or means, one sample or two samples, and that will help you decide, which set of kind of formulas and setups you will use. Right? So on your formula sheet, it lists off, this is for hypothesis test proportions, one sample, or this is confidence intervals with means and two samples, or something like that. And the formula sheet lists off all the pieces of information you need and the formulas that apply in that situation. Okay. Is this good? Yes, question?
So any questions that deals with means will have a standard deviation?
Yes, if the question is dealing with means, you will get the standard deviation of the sample. The sample standard deviation will be provided. Okay? don't get that mixed up with the standard error or the standard deviation of the sampling distribution, okay? Because that exists for proportions and means, right? You're going to have a standard error in all of these cases, but that's probably something you'd have to calculate or figure out. When we're talking about the standard deviation for means, it's going to be the standard deviation of the sample standard deviation. Yes?
So if there's two ends and both of them are the same number, is that still two samples?
Yeah, that's still two samples, right? If you have a sample of dogs, 20 dogs, and a sample of 20 cats, you still have N1 is 20 and N2 is 20. You still have two samples there. Okay? Okay, so let's start with this is a basic question. We're not gonna, I won't run the clicker for this one, but we'll say a researcher, can you guys read that? Maybe I'll make it a little bit larger. Okay, it says a researcher wants to know if the rate of teen pregnancy has changed. In 1995, the rate was found to be 8%. Recent study surveyed 1,200 randomly selected female teenagers and found that 103 had teen pregnancies. Okay, what situation is this? So in these ones, I don't have anything indicating whether it's a confidence interval or a hypothesis test, but you should be able to decide whether you've got proportions or means and one sample or two samples, okay? So this one would be a situation with what? And how many samples? Yeah, so this would be proportions, one sample. Okay, so that's our answer there. All right, over here it says a teacher wishes to know if the performance of his students has changed between quarters. Last quarter there were 150 students in his class. The average grade was 87% with a standard deviation of 12%. This quarter he has 160 students. Average grade is 90% with a standard deviation of 10%. What do we have here? Yeah, so this is means, and we have two samples, okay? So even though right here we have the value, 87%, okay? Don't be distracted by this percentage. It's still a numeric variable. We're talking about the average grade being a numeric score in the class, okay? So this is means two samples. The variable is the grade in the class, is the class grade, which is a numeric variable. Okay, is that all right? I'll post the answers, or this document online here. Okay, let's, now I want to cover some theoretical questions, okay? And so I've got a bunch of questions related to confidence intervals, and we'll run some clicker questions here. All right, so first of all, we ask, we'll say you create a 95% confidence interval for mu. The interval goes from 1.2 to 3.5. Are you guys able to read this? Should I? It's okay? No? It's not. I don't know how to make it brighter, okay? That is beyond my capabilities. But I can increase the zoom on my computer screen. I can do this. Is that better? A little bit? Yeah. Okay. All right, so this is kind of your, you create a 95% confidence interval. The interval goes from 1.2 to 3.5. True or false, our confidence interval provides evidence that the population mean is not 0. Okay, so get your clicks in there. True or false, you can ask your neighbor for answers. All right. Okay, what do we have? I'm going to go ahead and click stop here. Everyone get their clicks in? Okay, yes, that is correct. The answer is true. Okay. 0 is not inside the interval. So we have, okay, 0 is not a plausible value for mu. Therefore, we say we have evidence that the mean, hang on. Let me change my zoom here. Just want to make sure. Okay. I think this is the biggest I can make it. Okay. We say we have evidence that the mean is not equal to 0. Okay. Okay, what if we said you create a 95% confidence interval for mu, and the interval goes from 1.2 to 3.5, true or false? Our confidence interval provides evidence that the population mean is not 2.5. Okay, not a clicker question, but just go ahead and call out the answer. False, right? So 2.5 is a value that is inside the interval. Okay, so 2.5 is a plausible value for mu, and therefore we do not have evidence that mu is not 2.5. Is that good? Okay, what about this one? You create a 95% confidence interval for mu. The interval goes from 1.2 to 3.5. True or false, our confidence interval provides evidence that the population mean is 2.5. This one is false. Okay, we'll say 2.5 is inside the interval and is a plausible value for mu. Okay, however, the interval is never able to provide evidence that mu is equal to some exact value. Okay, the confidence interval is only able to say that these values are plausible, and it's never able to say that it is definitely equal to 2.5. So we have to say false. Is that okay? All right, let's do a we'll do a clicker question here. So we'll say you create a 95% confidence interval for mu. The interval goes from 1.2 to 3.5. True or false, there is a 95% probability that the population mean is between 1.2 and 3.5. Okay, so this one's a clicker question. Pick true or false here. You can consult with your neighbor what you think. Okay, sorry. We'll click stop here. Let's see. Okay, B is the correct answer. False. Okay, so our answer false. What we say is that, what's going on here? the population mean is a fixed value, and there is no uncertainty about it. Okay, so it does not make sense to talk about the probability of the value mu, okay? Because mu is set. Mu is a fixed number. It doesn't. It's like saying there's a 95% probability that 6 is between 1.2 and 3.5. Either that number is or is not in the interval, okay? Mu is either in the interval or it is not, okay? We just don't know the value of mu, okay? So we can talk about our confidence, but not about the probability, because it is a fixed value. Okay, what about this question? True or false, 95% of the values in the population are between 1.2 and 3.5. So our 95% confidence interval goes from 1.2 to 3.5, and now the question is, true or false, 95% of the values in the population are between 1.2 and 3.5. Okay, I'm going to go ahead and click stop here. Get your clicks in. Okay. Let's take a look. And the answer is indeed false here, okay? 95% of the values in the population are between 1.2 and 3.5. This is not true. The confidence interval is about the location of the population mean. It is not about the individual values in the population. Okay, so here's a counter example. I can be 90% confident that the mean household income in the USA is between, we'll say, 52,000 and 67,000, something around there. Okay, so I can be 90% confident, or sorry, 95% confident that the mean household income is between here and here. This does not mean that 95% of households have incomes between 52,000 and 67,000. Okay? So while the mean income, we can be pretty confident that the mean income is within this range, it doesn't mean that individual incomes are between here and here. Okay? In fact, there's a lot of incomes are going to be below this, and a lot of incomes will be above this. Certainly much more than 5%. Okay? So, many households, okay, much more than 5% will have incomes outside of this range. Okay? So the confidence interval is just about the mean of the population, not the Okay, what about this one? 95% of the samples will have sample means between 1.2 and 3.5. 95% of the samples will have means between 1.2 and 3.5. Yeah, this is also a clicker question. Okay. Yeah, this is today's clicker fiesta. Okay. Okay, I'm gonna go ahead and click stop here. Okay, let's see. All right. Okay. So this answer is also false. Oops. Okay. Again, we are not talking, the interval does not describe the locations of sample means. Okay. What is true is that 95% of sample means will fall within 1.96 standard deviations or standard errors of the population mean. That is true, okay? But it is not true, it is not correct to say that 95% of samples will fall within the range of a given 95% confidence interval. Okay? Because this confidence interval is based on one sample. Okay? If we created a range based on the population mean, that would be correct. But this interval of 1.2 to 3.5, that's based on some random sample and not the population mean. So it's not correct to say that 95% of sample means will fall within the range of the given confidence interval. What is the is correct? Is not corrected? No. Okay. Okay. Is that all right? All right. Last one on confidence intervals here. Okay. True or false? If 100 random samples were drawn from the population and each sample produced a 95% confidence interval, we would expect 95% of those confidence intervals to capture the true population mean. Okay. So you can discuss this one, true or false. Look. All right. Well, the answer is A. All right. All right. So this answer is true. Okay. This is the meaning behind 95% and the 95% confidence interval. Okay? Basically, the process of creating a 95% confidence interval means that 95% of intervals created what is this? 95% of intervals created will capture the true population mean. Okay? When we are given a random sample, okay, we do not know if this sample will produce a confidence interval that is correct, that captures the mean, or misses it. Okay, we are banking on the fact that 95% of them do capture the mean. Okay. However, it's possible that the confidence interval we created is one of those 5% that misses it. Okay. So when we create a confidence interval, we're basically saying, I'm 95% confident that it does capture the population mean, but there's also 5% of created intervals will miss the interval. Will miss the population mean. Yes.
I was a little misled by the last part about capturing the true population mean. I thought you would have to say like, 95% of those confidence intervals would have the interval blank instead of like saying capture the mean, because that sounded a lot like, oh, does this provide evidence that the mean is 2.5 or something like that?
Well, when we say capture the population mean, means that the population mean is a plausible value according to the confidence interval. That's what it means there. Okay? All right. Okay, so those are some questions regarding confidence intervals. Okay? Some conceptual ones. All right. Let's now I've got a bunch of questions for hypothesis testing. I hope you guys are ready for this. All right. Okay. I just did a silly example. I don't know if you saw. There's a show, I Love Lucy. They had an episode with Vitamita Vegemin. Maybe some of you guys saw this when you were like 8 or not. I don't know. Okay. Classic episode. All right. You perform a hypothesis test to see if the proportion of people who like Vitamita Vegemin is less than 75%. The p-value for this test is 1%. Okay? You used an alpha of 5%. So which of these statements, I should ask, which of these statements is the, I guess the best answer here, okay? So here we're asking, do we have evidence that the population proportion is 75%? We do not have evidence that the population proportion is 75%, or we have evidence that the population proportion is less than 75%, or we do not have evidence that the population proportion is less than 75%. So this is kind of the question that we are working with. All right, let's take a look here. And C is the correct answer. Okay, all right, so correct choice is C. Okay, so in this case, the alternative is less than 75% of people like the product, and with the p-value, that's what we would accept here. Okay. We'll relax on the clicker buttons for a little bit here. Okay. So here we'll just call out the answer. Okay. Same question. All right. Same setup. The proportion of people who like this is less than 75%. The p-value is 0.01, and we use an alpha of 5%. Which of these do we use? Okay, so the keyword here is we're talking about support. Do we have evidence to support the null, evidence to support the alternative, or what? Okay, so what do we choose here? Okay, when we're talking about the supporting, we only talk about supporting the alternative. Okay, the correct answer choice here is C. Okay, the evidence or our data is only used in the context of supporting the alternative hypothesis. Okay, it's the evidence is not used to support the null because we always assume the null to be true. We always assume that the null hypothesis is true, and we will just continue to assume that the null hypothesis is true unless there's enough data to convince us otherwise. Okay? Okay, what about this one? Same setup. Is it less than 75%? The p-value is 1%. You use an alpha of 5%. Which is the best answer here? So the keyword here, we're talking about rejecting. So which is the correct answer choice here? Okay, the correct answer choice here is A. Okay, we only consider rejecting the null hypothesis. Okay, again, we begin by assuming that the null hypothesis is true. And we do not assume that the alternative is true. Okay, so if there's not a, so it doesn't make sense to talk about rejecting the alternative hypothesis. Okay. All right, is that okay? All right, here's a question here. Let's we'll do a clicker question with this one. It says you want to create a hypothesis test to see if the proportion of North Campus students, which we'll call population 1, who reads novels for pleasure is greater than the proportion of South Campus students, population 2, who read novels for pleasure. Okay, what would the appropriate hypotheses be? Okay, and here we have exclamation equals means not equal to. All right, so this is your null and alternative, null and alternative, null and alternative, null and alternative here. Okay, go ahead and get your clicks in here for this. Okay, did everyone click here? Okay, I'm going to go ahead and click stop. Okay, all right. This one looks, apparently it was quite easy. Okay, and so the correct answer is C. Okay, the null hypothesis always has an equal sign. Okay, so so that reduces us to A or C, and then the question asks if we have evidence that P1 is greater than P2, so we choose the alternative, P1 greater than P2. Okay. One more clicker question here. This is based on type 1 and type 2 error. Okay. It says doctors can administer an STD test. The test would assume that the person is disease-free unless they show symptoms of having a disease. Patient is disease-free would be the null. Patient has an STD will be the alternative. Which type of error is worse? Okay. And whether would you want to use a large or small alpha? I guess we'll say from a public health perspective. Okay. So think about what it means to make a type 1 error. What does it mean to make a type 2 error? Which one is worse from a public health perspective? And does that mean you'd want a large or small alpha? Okay, let's take a look. And C is indeed the correct answer. Okay, a type 1 error would be a healthy person is flagged as having a disease, whereas type 2 error would be a person with a disease is told they are healthy. Okay, so from a public health perspective, the type 2 error is worse because it can result in further transmission of the disease. Okay, so hang on, you guys. We would prefer to use a large alpha and increase the risk of type 1 error in order to reduce the risk of type 2 error. Okay, so that's what we have here. I'll post these this note sheet or these answers up online, and you guys can use that to study. And with that, we'll end here for today, and we'll see you guys on Friday.